I'm going to try it. And I hope that you really love this, guys. Okay. So it says, while we could just give the formula for cosine A minus B, I don't want to turn you guys into a robot. We'll derive this formula and see what's up. So draw the first quadrant and exaggerate the unit circle. Just the first quadrant. So do that real quick. And I'm going to call from the center to some coordinate, I'm going to call this angle A. And with a different color, I'm going to call that angle B. So this in green is A minus B. Have we done anything crazy yet so far, guys? Okay. So if this one here is angle A, then your x coordinate here has to be cosine of A, and your y coordinate has to be sine of A. Is that making sense so far? Okay. So with the blue one, with the blue line, it's the same deal. That blue coordinate, it has to be cosine of B, sine of B. So here's what I want. Do you guys see, well, I guess I'll just tell you bluntly what I want. I want the distance between those 2 points. So hopefully you remember from your geometry days that I have a right triangle right here. And I can use Pythagorean theorem. So if I can use Pythagorean theorem, that means, and I'm going to call this distance d, or little d, I guess. And I can say Pythagorean theorem says that the difference in horizontal displacement, so I'm going to say, let's see, I'm here, so the difference from horizontal is cosine B minus cosine A. And I'm going to square that. Plus the difference in vertical displacement, sine A minus sine B squared, equals the hypotenuse squared. Does that make sense to you? Okay. All I'm going to do, guys, is expand it. So check it out. Cosine B times cosine B. That is cosine squared B. And then when I do cosine B times cosine A, that's cosine A cosine B, because you want to put the first letter first, right, because in the alphabet. And you're going to have two of those. So I'm going to write minus 2 cosine A cosine B. And then when I do negative cosine A times negative cosine A, that's going to be cosine squared A, but positive. Does this make sense so far? All I'm doing is expanding. Now let's expand this guy. So sine A times sine A, that's going to be sine squared A. Sine A times sine B, that's going to be sine AB, but you're going to have two of those. So minus 2 sine A sine B. And then plus, because negative times a negative, sine B times sine B is sine squared B. And all that still equals D squared. So get up to there. Any questions so far, guys? All right, here's what I'm noticing now. I'm gonna pair these up. I see a cosine squared B and I see a sine squared B. Notice that I put one underline for those. And I see a cosine squared A and a sine squared A. And when I pair those up, what is cosine squared plus sine squared of the same angle? It's the Valentine's formula. Do you guys remember? It equals 1. So that equals 1. So I'm going to rewrite it just so you guys can see. Cosine squared B plus sine squared B plus cosine squared A plus sine squared A minus 2 cosine A cosine B minus 2 sine A sine B. Oh man, I didn't want to get into this guy. Equals D squared. This right here, and I'm just circling them in red. It doesn't mean that it's related to anything over there in red. That right there is 2, because this is a 1 and this is a 1. So it's kind of cool. It's like a little puzzle. So check it out, guys. Here's what I finally have. I have 2 minus 2 cosine A cosine B minus 2 sine A sine B, and all that equals D squared. And now what? You're like, okay, Chavez, now what? Leave it alone for now. We're going to do something really cool, guys. It's I didn't steal this idea. I saw it a long time ago somewhere. And I'm like, man, that's a pretty smart. I think it was Mr. Paul Forrester. So here's what I'm going to do. Did everyone catch up to here? Did everyone already write all this down? Okay. So just listen to this, guys, because I really want you to understand the logic. So pretend that I can move this angle, the A minus B part. Can you guys see that little white dot on the screen or not really? No? Like, do you see a little white little scroller? Okay. You don't see it? Okay. What if I do this? Do you see like a white circle? No? Oh, that sucks. Okay. Well, pretend that I can rotate it at the origin. So if I can rotate at the origin, don't write anything down just yet. I'm going to draw the same unit circle again. Don't draw it down. I need you guys just to listen right now. I'm going to see if I can do it again. And I'm just going to rotate the A minus B. So this angle that you see is A minus B. So here's that blue line, and here's that red line. It's the same deal. And then let me put here in green. I'm trying to emulate this angle right here. All I did was rotate it clockwise, where now this is the origin, 1, 0, the origin. That's the unit circle 1.0, on the vertice. It's just a point on the unit circle. And this guy is just this point up here. It used to be cosine A, sine A, but it's this point right here. It's the same point, but now I just translated it. So now this point here is cosine of A minus B, sine of A minus B, because I'm just doing it in terms of this angle A minus B. Does that make sense, guys? Okay, go ahead and draw that, guys. So catch up real quick. I did a really bad job. The triangles are not going to look the same. Darn it. Next time I'll see if I can utilize the copy paste feature, guys. I tried to do, so this distance here is the same distance. We're talking about that D is this little d. They're the same. I just did a really bad job of drawing because I'm going to tell you guys something. I think I already told you guys. I'm very embarrassed by this. I have a D in my transcript, and it's the very first line. I'm not even kidding. It's the truth, the honest truth. I have a D on my transcript, guys. It's the very first line. And I don't know if you guys care. You guys probably don't care about this, but I got a D in art. And I know it's super embarrassing. I don't like to show people my transcript because it's the very first line. I have a competitive GPA. I'm cum laude, and I have a 4.0 math GPA. But yeah, I got a D in art. So don't ever, if you're failing a class, just remember that Chavez failed art. So you can't get any lower than that. All right, so here we go. This triangle is supposed to be the same triangle as that one up there, guys. It's supposed to be. So I'm trying to say I want to find that D again, or the little d there. So I'm going to write D squared, or I guess I'll do Pythagorean theorem first. So the horizontal displacement, so I'm going to go 1 minus, and then this coordinate up here, that's the x coordinate right there. So cosine of A minus B. close it, put a square on it, plus the vertical displacement. So sine of A minus B, and if you want to be minus 0, this coordinate down there is 0, the y value squared, equals d squared. So right there. Did anyone get confused by that one line? Anyone confused? No one confused? Everyone's okay? Okay. Hijazi, you doing okay? You understand this one? All right, all I'm gonna do is expand, guys. That's all I'm gonna do. I'm just gonna square that. So it says squared, 1 times 1. I'm gonna come over here. 1 times 1 is 1. And then 1 times cosine A minus B is cosine A minus B, but I'm gonna have 2 of them. So minus 2 cosine of A minus B. And then negative cosine A minus B times negative cosine A minus B, that's a plus cosine squared of A minus B. And then sine A minus B minus 0, that's just sine A minus B. So I'm just going to drop the 0 and just square the sine A minus B. So plus sine squared of A minus B. And all that equals d squared. Again, and don't worry, I'm trying to go slow, guys, so you catch up. Again, I want you guys to recognize that's 1. So now that we see that we have another 1, 1 plus 1 is 2. So here's what I can rewrite. 2 minus 2 cosine of A minus B equals d squared. So catch up to there.
Wait, Chop, sorry.
Oh, it's all good.
This might be like a dumb question, but how do you know that it's 1? Like,
we proved it on, I can't remember the name of the notes, but we proved it that cosine squared plus sine squared equals 1. I guess the copycat answer is just, what's the copycat answer? The unit circle, the equation of the unit circle is x squared plus y squared equals 1. And remember that x is the same thing as cosine theta, and that y is the same thing as sine theta. So this is a cop-out answer. So I can replace the cosine and sine with that expression. Oh, I put the letters in the wrong one. That's x, this one's y. So I can rewrite this as cosine theta squared plus sine theta squared equals 1. So now you got a nice, beautiful expression that cosine squared plus sine squared equals 1, as long as your periods are the same.
oh, okay, thank you.
That's a cop-out answer. There's a better answer than that, but it would take a whole lesson. But is that okay for now, Ms. Vasquez?
Yeah, it's good. I was just like, I didn't know, because in the first one, I was just like, oh, like whatever, but I didn't know it'd come up again.
Oh, it's all good. And Valentine's Day is coming up, guys. So for Valentine's Day, I'm telling you, you got to tell your boy or your girl, you know, we don't judge. You got to tell them, I'm cosine squared and you're sine squared, and together we are 1. And if they don't get it, you know, just dump them. Get yourself another one. Upgrade and get yourself a bigger, badder boy or girl or whatever you guys do nowadays. Okay, anyways, let's get back to math here. All right, guys. So now that we have these expressions, remember, these are the same. This d squared is the same as that d squared. So I'm going to set the expressions equal to each other. I'm going to set them equal to each other. So I'm going to write, what am I going to write first? I'm going to write this one first. I'm going to write 2 minus 2 cosine A minus B equals, and yes, I did write some space here on the second page intentionally because I knew I was going to go into it. 2 minus, let me write that. Let me zoom out so I can see it. 2 minus 2 cosine A cosine B minus 2 sine A sine B. All of those 2 equal d squared. I'm not going to bother with the d squared anymore. I just needed it for that. All right, the next thing I'm going to do, guys, and I'm going to go slow. I need to get rid of that number, and that's simple to do. You can just subtract 2, and when I do that, I subtract 2 on the other side, and they go away. So now, and here in the next page, I said that funny. I'm going to go ahead and just rewrite my statement. I have -2 cosine of A minus B equals -2 cosine A cosine B minus 2 sine A sine B. So catch up to there. We are so close, guys. All I'm going to do now, guys, I just want to get rid of that -2 in the front of the cosine. So all I'm going to do now is just divide by -2. Whatever you do to one side, you do to all of them. And now you have this beautiful expression. Look at this. Look how awesome this is. This is your composite argument property for cosine A minus B. It's a formula. And I want you guys to see, I could have been very boring. Well, I mean, I hope you don't think I'm boring, guys, but I could have been very boring and I could have just said, here's the formula and we're going to use it. And there it is. It's right here, written in little gray. I wonder where I got this from. I think it was Mr. Forrester's. Written in gray here. Cosine A minus B equals cosine A cosine B plus sine A sine B. But how boring would that have been if I would have just told you that? Isn't it better that we derived it? Look, let's reflect. Look at all the math you did to solve that. Doesn't that look beautiful? I mean, I think it looks beautiful, guys. In some ways, it kind of almost looks like art, which is ironic because I failed art, but it does. In some ways, it looks like art, guys. I hope you enjoyed it. I really do. I enjoy this all the time, every time I see it. Okay, so maybe you're thinking, all right, Chavez, so I learned this formula. What's the point of knowing the formula? I don't understand why we had to know it. It's because we're able to, this is what we did last time. Here's a cosine with a one single phase displacement. And now if I want to go into a linear combination, let's say I want to have 7 cosine theta minus 23 in terms of cosine and sine, there's a way to do it. So how do I do it? With this. That theta is like A, that 23 is like B. See, so now I can rewrite it and I'm going to go 7 cosine theta minus 23 degrees is equal to 7, and I'm going to put a bracket. What am I doing? I'm doing this right here. Cosine, the theta is like A and the 23 is like B. So this says cosine A, so cosine A is cosine theta. And then it says cosine B, so the B is 23, so I write cosine 23 degrees. And then it says plus, so I write plus sine theta, sine 23 degrees. And bracket, close. Now I'm just going to distribute the 7, guys. So 7 cosine theta minus 23, and I'm going to rewrite it. I want to put the cosine 23 in the front because that's a number. So 7 cosine 23 degrees, cosine theta, plus 7 sine 23 degrees, sine theta. Chavez, why did you do that? 7 cosine 23 and 7 sine 23, those are numbers. We're going to find out what those numbers are. So write that down really quick, guys. I'm going to open up Desmos really fast. So hopefully you had time to write it, guys. So here we go. I'm going to go ahead and share my screen for Desmos. And I'm going to make sure first that my mode is in degree mode. And I'm just going to type what I had. 7 cosine 23. 7 cosine 23 degrees. Make sure you're in degree mode. And I get 6.444 if you round it. So let me go to the next. Let me go here. And I'm going to go 6.444 cosine theta plus, and now let me go back and see what 7 sine 23 is. And I just go 7 sine 23. And that is 2.735. 2.735. I can remember that. 2.735 sine theta. And there it is, guys. That's it. It was a little more cumbersome, but it's easy. If you don't understand the theory, that's fine. It's easy. You just follow the rule. I know the rules, and so do you. Well, I think there's a song or something like that, or I don't remember. Okay, and there it is. And it really is that simple, guys. All right, let's keep going. Hopefully you're enjoying this for Monday morning here. Oh, wait, it's Thursday morning. Man, what the heck? Got my days all messed up. All right, this is just a review from yesterday. It says you can use linear combination properties to solve certain trig equations algebraically. And I have this equation here, and it says verify the solution graphically. Okay, no big deal. So I'm in radian mode, so I want you guys to notice that first. Radian mode. All right, the way we have it right now, we cannot solve. Turn this into a cosine with one phase displacement. Turn into cosine with phase displacement. Or you can just turn into cosine. So how do I turn it into cosine? I make a little grid. I go -2 and then +3. So -2, +3, not to scale. I draw my little triangle. There's my right triangle. And then I find my amplitude. The amplitude is equal to the square root of -2 squared plus 3 squared. Oh, some of you guys are telling me that when you square a negative number, it stays negative. I know because I graded your homework. Yeah, it turns positive, guys. Put parentheses in case you're having issues with that. 3 squared is 9, 2 squared is 4, 9 plus 4 is 13. 13 does not break down, so leave it as 13. Now I need my angle. I'm going to do arctan of 3 over -2. I know that's going to give me an answer in quadrants 4. So whatever number I get, I'm going to add 180. Wait, I'm not in degrees. How come you guys didn't tell me anything? I'm going to add pi. Why am I adding pi? Add pi to get in quadrant 2. So I'm going to do that. So let me go to Desmos. 3 over -2. So let's see. I'm going to go back to, first I got to turn it into radians. All right. And then I'm going to go arctan. Don't worry, guys. We're almost done. Arctan of 3 divided by -2. I hope I wrote it correctly. And there it is. And I'm going to add pi to that. Plus pi. So there it is. I just got a text from someone. 2.159 if we're going to round. 2.159. Okay, so let's go to 2.159. Uh-oh, did I do it right? Yeah, I think I did it right. So here we go, guys. Let's rewrite it. So now I can rewrite this as -2 cosine x plus 3 sine x equals nothing more than square root of 13 cosine theta, or no, they have the variable x instead of theta, x minus 2.159. All right, don't worry, we're almost done. We're so close, guys. All right, so what do we do to solve this? Here's what we're gonna do. And actually, next time I'm gonna use prettier numbers because I don't like all these not pretty numbers. So we're gonna rewrite equation. So square root of 13 cosine of x minus 2.159 equals 2. And now we just solve for x, just like we've done it the first semester. So how do you solve for x? Divide by square root of 13, divide by square root of 13. Oh, some of you guys like to write one continuous line. See if you can stop with that habit, guys, because there's an equal sign, so you got to break. You got to stop your little line there. I think Torres would do that all the time, and I would be like, Torres, why do you do that? And Torres be like, oh, that's how I've always done it. And like, no one's ever told you anything. And you're like, no. Like, so I think you guys pick up on our habits, which is fine, but just, yeah, stop with that. Now we're going to solve for cosine. So inverse cosine, both of them, guys. X minus 2.159 equals plus minus. Remember that the cosine, arc cosine has a plus minus in the front. Arc cosine of 2 over square root of 13 plus 2 pi n. And then just move the 2.159. So x equals 2.159 plus minus arc cosine of 2 over square root of 13 plus 2 pi n. And I'm going to call it x1 and x2. And I'm going to find out what that number is. So I'll wait for you guys to catch up while I look at this message here. That's the soccer players. They're saying they're not going to be here. So they want all the lessons recorded and uploaded to YouTube. So I'll get to it eventually. All right. So here we go. All I'm going to do, guys, is just plug it into the calculator. And it's that simple. So let's see. I'm going to go back to Desmos. And let's see if I can remember. So I want this number, 2.159 plus, did I have anything in front of the arc cosine? I didn't, right? Arc cosine of, was it 2 over square root of 13? Okay, 3.14, oh, I bet you I would have gotten pi there maybe. Well, 3.1418 is one of them. So let's go to 3.1418 plus 2 pi n. And maybe that's too many digits. Maybe I should just go 3.142. Because that one might not be accurate, the fourth one. And I'm going to change a plus to a minus and see what I get. And I'm going to change that plus there to a minus 1.176. 1.176. All right, guys, don't worry. We are almost done. I trust me. All right, final answers. I'm looking from what to what? Negative 2 pi to 2 pi. So that means I'm probably going to have two blanks, a blank, comma, and then 1.176, comma, 3.142. I cannot add 2 pi to those because it would take me outside the domain, but I can subtract 2 pi from those two numbers. So I'm going to go back to my Desmos, and I already have it here, guys. So I'm just going to go minus 2 pi, So one answer is negative 5.107. That's going to be this one. Negative 5.107. I hope I wrote it right. And then the other answer is going to be negative 3.14 because we're subtracting 2 pi from it. So the other answer is going to be, let me change that to a plus, negative 3.141. And there it is. Those are my answers, guys. We're going to see if we're correct. Okay, let's see if we're correct. So I'm going to go back to Desmos. And I know it's a lot, guys. I know maybe I should have cut this lesson into 2 lessons. So I'm going to go back to Desmos, and I'm going to type in the original equation that I had. And I already forgot the original equation. What was it? It was negative 2 cosine plus 3 sine. And that equals 2. So I'm going to write negative 2 cosine x plus 3 sine. And then on the second one, I'm just going to type in the number 2. Oh, y equals 2, not just 2. Y equals, and we're going to see where it intersects, guys. So let's see. Did I get a solution of negative 5.107? Yes. Did I get negative pi? Negative 3.14. Check it out. It even knows it's pi. That's cool. I didn't know Desmos was that smart. So we're supposed to actually get a perfect pi, but you know, I rounded too much. Did we get a 1.176? And this one should be pi. Yep, pi 2. There it is, guys. We did it. Good job. We did it right. All right, let's see what the last question says here. Express 7 cosine 2 theta minus 120 as a linear combination of cosine and sine. Okay, these are the easy ones. All we're going to do is use this formula. Use, and just scroll up, and you can see the cosine A minus B. Oh, not A minus A. And that is cosine A cosine B plus sine A sine B. All I'm doing, guys, is this formula right here. The one we derived. So that's what we're going to do. This one's a perfect angle. Good. So 7 cosine of 2 theta minus 120 degrees is nothing more than 7. And I'm going to put my little bracket. So here's what the bracket goes in. And I'm going to write cosine A. So I'm going to write cosine. The A is like 2 theta. The B is like 120 degrees. So cosine 2 theta, cosine 120 degrees, plus sine 2 theta, sine 120 degrees. And you don't need those parentheses if you don't want to. I'm going to distribute the 7. 7. And I'm going to write the cosine 120 first because that's an actual number. Cosine 120 degrees, cosine 2 theta, plus 7 sine 120 degrees, sine 2 theta. And I'll wait for you guys to catch up. See, guys, in the past, I couldn't tell whether you guys were caught up or not. I would just see blindly. But now I can see. So hopefully you are getting a better notes experience. Okay. I don't know. I think it's cool. This is not quite a class yet, but it's getting there. It's almost like we have it's almost like you guys are here. You guys are here in spirit. All right. Cosine 120. Look at your unit circle. If you have it memorized, even better. But if you don't have it memorized, no big deal. Cosine 120 is in quadrant 2. That is going to be a negative half. Sine 120, we're in quadrant 2. That's going to be a square root of 3 over 2. And I wouldn't leave it like that, guys. I mean, you can, but it doesn't look, I mean, make it look nice. Negative 7 halves. Cosine 2 theta, sorry. If you wanted to put it in the decimal, you can, I guess. But this is a perfect answer. Plus 7 square root of 3 over 2. I better change that 7 to like an 8. So it can go in nicely. Sine 2 theta. And there it is, guys. That's my answer. That's what they wanted. If you graph this expression in degree mode and you graph this expression in degree mode, they would be the same. All right, let me get my tablet here in primary mode. So let me go back.